Great. Well, thank you so much. It's a pleasure to be back moderating again for a Urban Green panel on a really timely subject that obviously has become a focus of great interest. So what I'm going to do is just, in addition to moderating, want to go over quickly what today's program is. What we can do is I'm going to give a short sort of introduction, high-level presentation to kind of set up the topic a little bit, which I think will sort of flow in nicely to the panelist presentations, which will proceed directly from that. Each panelist will speak for about 5 to 7 minutes, and then we'll go right into discussion and Q&A. I'll be leading that conversation and kick off with a couple of initial questions, but then what I would like to do, following what Caitlin just mentioned, is really start to incorporate the questions from our audience. So please do use that Q&A chat box and share questions, and I'll probably group those together thematically. So going ahead and getting started, just to set us up. Oops, here we go. I really just want to sort of first, I think before we get to the utilization of carbon within concrete, to really first high level really drive home what is the connection really between concrete and climate? Why is concrete an interesting subject or necessary subject to talk about in regard to climate? And what I found is I think that it's useful to sort of think about it on 3 different sort of levels, sort of almost like a Russian doll. The highest level, I think it's just really significant to drive home that much of the concrete climate story is just about how ubiquitous it is, how universal it is, that it's everywhere. It's the second most used substance on Earth after water, and we produce upwards of 30 billion tons of it globally per year. But in addition to its being everywhere, it's that it's likely here to stay as well. It's not really going anywhere. And that's obviously a huge part of the story, certainly within a meaningful time frame for the climate. And that's just because it's an irreplaceable material in terms of its versatility, durability, but it's also, even if there was something that could magically sort of step in to replace it, it's so deeply ingrained in our construction practices, our standards, and our codes that just that process alone would take decades. And then, of course, it's abundant. The materials that make it up are widely available and accessible everywhere. So it's difficult to think of a material that could stand in for concrete given global construction growth rates. And then on the lower level, which a subject that is obviously very familiar to an urban green audience, is the emerging and important idea of embodied carbon and how we think about this within the context of climate change. And this is obviously a concept whose time has come, and it's really sort of surged in importance. And there's a good reason for that. And I know this audience, doesn't really need a definition, but by embodied carbon, we're talking about the carbon or greenhouse gas that are emitted in the process of making things rather than operational carbon, which is using things. With concrete, we're mostly, though not entirely, really talking about the embodied carbon of the material. And this is, again, not just sort of an academic, sort of point here. This is critically important that we tackle embodied emissions. It's going to, over this critical next 30-year window of action, it's estimated that, up to half of that, of our emissions will really come from embodied carbon, and they're all front-loaded. They all happen at once up front. So this is an area of action that we need to proceed with. And again, when you think of within that, we have to examine and make progress on every building material. But again, because concrete is just so pervasive and has such staying power, it's really going to be sort of central to our efforts to curb embodied carbon in the built environment. And now for the most, sort of specific sort of layer to think about is, well, what are the real emissions factors that we're talking about when we're talking about concrete? And we're actually, for the most part, really talking about one essential ingredient, and that's Portland cement, which is the main binding ingredient of concrete. It typically makes up about 10 to 15% of the volume of concrete, but it accounts for 85, 90% of the emissions. And when you add that up globally, it's estimated that Portland cement emissions are responsible for about 7 to 8% of total global emissions, which would make it, if it was its own country, the 3rd largest emitter. So a really high source of emissions. And a lot of that just has to do with how cement is made, the sort of some of the unique production factors in making clinker, the main ingredient in cement. That takes an enormous amount of heat. It's from limestone. You have to break it down and heat it up to really high temperatures, and that has an emissions tied to it. But just breaking down limestone itself generates or releases an enormous amount of carbon. That's actually the largest share of emissions from cement, the calcination process. And that's really key in what we're going to be talking about today, about why CCUS is carbon capture, utilization, and storage is necessary. So when we're talking again about reducing the embodied carbon of concrete, that very much relates to the status of Portland cement. And there's many different things that we can do right now, or already are doing, that are off the shelf, ready to go, cost effective, and actionable that can help us drive down that embodied emissions. Certainly cement plant efficiencies and fuel switching are key to that. We've already made great progress on that. Using lower clinker blended cements, such as Portland limestone cement, very doable right now. And then certainly what many folks tuning in right now are familiar with, the use of various substitutes for cement within concrete mixes, or supplementary cementitious materials such as fly ash and slag, silica, fume, and more up and coming SCM such as ground glass pozzolan. But if we really want to squeeze all of the carbon out, which we need to get to carbon neutrality, we need to do more than those substitutions or reductions of Portland cement. And this is where the subject of today is really pertinent. And we're going to have to make major investments and see a really accelerated deployment of various carbon capture, utilization, and storage technologies. And our panelists today each represent companies that are really at the forefront of this very diverse and expanding sector. But just to summarize again what we're talking about, sometimes when people hear that, they think of one thing, and it's actually, again, it's many different things already, even though we're still early days. There's a lot of different technologies and applications that fall under the CCUS umbrella. Here we're talking about, in terms of looking at it in a process, this includes the actual capturing of CO2 from cement plants, which is essential, again, given how carbon intensive it is. Then what do we do with that carbon? That includes the geological storage of that carbon, but it also, importantly, and we'll be talking about this extensively today, it's about taking that carbon and storing it in things or utilizing it. And that includes concrete as well as other materials. And concrete actually naturally has the characteristic of actually absorbing carbon over time, the carbonation process. And many of the new methods and technologies that we'll need to see implemented take this capability and take mineralized concrete, and they use it as components of the concrete itself. And what's exciting about it is this too is very, very diverse. And you'll get a preview of this from our panelists today. CCUS applications span the entire supply chain. We're talking about every major component, from cement to aggregate to SCMs, and then the final concrete product can have CCUS applications that map onto it. And that includes the different types of concrete products that we use, from ready mix to blocks and precast as well. So a lot of opportunity for intersection. And one thing I want to stress to end is that, again, we're not talking about a nice to have, isn't this a cool technology, or technologies? They certainly are. But really, CCUS has to be, because of that calcination part, it has to be a major part of decarbonizing cement and therefore concrete. In fact, some estimates think, point to upwards of half of emissions will have to be reduced through CCUS. This is echoed again by a more recent McKinsey & Company report. And but what I'm excited about, what actually took me to this space, I come from a solar background, what kind of brought me into concrete a couple of years ago, is this really exciting opportunity of exceeding carbon neutrality. Can we do better than just making carbon not harmful? Can we do better than neutral? Can we possibly actually get to a point where concrete, this most common building material in the world, goes negative, where we can actually put more carbon or store more carbon from its production in its use than is emitted in its production? And this is not just a sort of a pipe dream. This is, I think, what many of the people that you'll hear from today all share this long-term aspiration. And I'll just leave with a great quote from a recent paper that was just published by Jeremy Gregory, who's the executive director of MIT's Concrete Sustainability Hub, is that we really could be, the framework or the bones are in place really to see concrete functioning globally as a carbon sink at some point. So again, that should be our sort of aspirational goal. And we'll discuss that goal actually during our discussion. And again, when you think of concrete as, again, it's everywhere, how pervasive it is, and that it's here to stay, if we can achieve that carbon negativity, that is not trivial in terms of addressing climate change. So couldn't be more excited by the folks who we have on today's panel to help us discuss that and to provide actual real world examples of how this is actually taking shape. Each of them is going to present a little bit about their company in turn, but I'll just quickly introduce them right now, and we'll give more extensive introductions when they each present. We have Christy Gamble, who's the Senior Director of Sustainability for Carbon Cure Technologies, Apoorv Sinha, who's the founder and CEO of Carbon Upcycling Technologies, Rahul Chandure, who's the CEO of CO2 Concrete, and Brett Henkel, who's a co-founder and VP of Strategic Accounts and Government Affairs for Svante Inc. And Brett is actually going to kick us off and present first. Brett, if you're ready to share your slides. Great. And what I'm going to do while Brett's getting ready is I can just tell you a little bit more about Brett and his background. 1 second. As I mentioned, Brett is the co-founder and VP of Strategic Accounts and Government Affairs at Svante. In his leadership role with the company, was instrumental in creating the process and the hardware used to prove technology's effectiveness, as well as mobilizing external support throughout the path to becoming a successful innovation. Prior to launching Svante, Brett was the program manager for AirQuest Technologies' compact hydrogen production system. And Brett received his Bachelor of Science in Physics with distinction and a mechanical engineering degree from the University of Victoria. So thank you, Brett. Looking forward to your presentation.
Thank you, Chris, for the introduction and the excellent slides that you presented. I just want to talk a little bit first about our target applications. You know, Svante is going after second generation CO2 capture. We're using solid adsorption, and when we talk about CO2 capture, we really mean the purification of the CO2 out of the flue gas. So there's two sides of the coin when you talk about CO2 capture. One is taking the CO2 out of the flue gas, and one is actually trapping it in another product, or converting it, or putting it under the ground and capturing it there. So Svante is concentrating on this, on the CO2 capture, the purification of the CO2 out of the flue gas. Now, you know, CO2 emissions, what's been in the limelight over the last 20 years is really the transportation sector and the power sector. Now, there's a lot of ways of dealing with the transportation, being battery electric vehicles and hydrogen fuel cells, and for power, renewables have made amazing progress over the while. But what's under the radar a bit for the last 20 years has been industrial emissions. So I like to talk about four things that touch everyone's life on a daily basis, and that is concrete. We build our cities and roads and bridges with concrete. Fertilizer comes from fossil fuels. We feed the billions of people in the world with using fertilizer. Plastic is pretty much in everything we touch on a daily basis, and steel. Imagine a life without steel. So all of these products that we use have CO2 footprints that are difficult to abate. And Chris has gone into cement as being, I would say, probably the #1 material that we use on a daily basis that is very hard to abate. And we believe that it's going to have a home in 2050. CO2 capture is going to have a home on cement, because we want to keep using cement. And it's very difficult to produce cement without producing CO2 emissions. So now I'll go a little bit into our technology. Our technology is based on a material called a solid adsorbent. This adsorbent grabs onto CO2 and lets nitrogen pass. Okay, so it's a very specific material that Svante is developing on its own and with partners. We then take this material and we put it into what looks like a filter. Okay, and we put this filter in a rotating wheel that actually produces the streams that allow the flue gas to go into the filter. The CO2 is trapped on the material. The nitrogen passes and goes up the stack. Nitrogen is fine to release to the atmosphere. And then in another section, low pressure steam comes in, heats up the material. The CO2, pure CO2, comes off. And then there's one more section of the process where the air is introduced into the material to cool the material. And then the whole process starts again. So this material and this form factor, this filter structure, allows for very high efficiency, very fast heat transfer, and most importantly, really, really low pressure drop, because flue gas is under atmospheric pressure, and you cannot compress it because it's very expensive to compress flue gas. So you want a very low pressure device to do this separation. So that's a very quick explanation of our technology, but at another time I'd be happy to go into more in depth with anyone on that. We're happy to say that in the 2019, we started up our flagship CO2 capture plant with Husky Energy in Saskatchewan. It's a 10,000 ton per year plant, 30 ton per day. And it's operating right now. It's giving us fantastic performance. We wrapped our entire process into a building to keep the operators warm. It does get minus 40 degrees Celsius in Saskatchewan in the winter. So we're quite happy with this with our pilot plant, and we're going to continue operating this pilot plant to show durability of the process. We have a program going with Lafarge Holcim in Richmond. This is our technology development program with Lafarge. We are actually demonstrating the full value chain of CO2 capture. Well, actually, even before that, dealing with the contaminants, CO2 capture, and CO2 utilization. So, there's quite a few different aspects to dealing with CO2 and flue gas from cement. So we split it into 3 phases. First phase we completed in 2019 was really understanding the contaminants in cement flue gas. There is SOx, NOx, particulates, and other heavy metals and whatnot in the flue gas. So it's fairly challenging from a CO2 capture perspective on that. So we've spent a lot of time understanding in depth the composition of the flue gas and the dynamic nature of a cement plant. It does turn off and on. It changes the type of fuel that they're using on a constant basis. So we had to understand the flue gas in depth. We are now just starting up a 1 ton per day CO2 capture plant to really show that our new specific material, the adsorbent material that we designed for cement, will prove its efficiency and durability on the cement flue gas. And then the final stage will be phase 3, where we actually were partnered with companies such as Carbon Cure and Carbon Upcycling to do convert the CO2 or trap the CO2 into concrete or into fly ash, and these folks will talk more about that. Now, technology development is all fine, but what we're really going after is a commercial CO2 capture plant on cement. Cement plants tend to be quite large emitters. They're in around 2,000 or 3,000 tons per day of cement. And our flagship commercial target for CO2 capture is the Lafarge Holcim plant in southern Colorado. It is actually a very large cement plant. It's 5,000 tons per day. And we have set up a powerful consortium to go after this opportunity. Svante is the technology provider for the CO2 capture. Total Energy is a sponsor of the project. Kiewit is the EPC on the project. Kiewit is the EPC that built Petronova in Texas, the largest CO2 capture plant in the world. Of course, Lafarge Holcim is the emitter, and Occidental Petroleum is the offtaker. Now, why was this CO2 cement plant targeted? It is because we're leveraging existing CO2 infrastructure. There is a CO2 pipeline that actually takes natural CO2 right now from southern Colorado and sends it down into the Permian Basin. We are in striking distance of that pipeline and are going to connect to that pipeline. And that CO2 can be sent down either for sequestration or for enhanced oil recovery operations. Either way, the CO2 gets trapped geologically. Now, we have another program going on with Chevron. We're building another 10,000 tons per day plant to go into California. And this is specifically at an intermediate step to prove out the new metal organic framework adsorbent that they are targeting for cement plants. And that'll be up and running in late this year or early next year, up and running in California. So we're quite excited about that. So we have all the steps in place to scale up to commercial capacities and the large capacities of CO2 capture that the cement industry requires. So that was very quick. I'm happy to answer questions after, but that's a snapshot of Svante and our projects. Thank you very much.
Thank you, Brett. That was excellent. We did get some really great questions that have come in, which we'll again raise during the discussion. Appreciate it. So we'll move on from cement and Svante, and our next speaker will be Rahul Shandore from CO2 Concrete. Rahul, if you can hear us and put your slides up, I'll go ahead and tell folks a little bit more about you. Rahul is the CEO of CO2 Concrete. He started his career as an engineer with GE's plastics business and has spent most of his 25 years since commercializing climate tech innovations, ranging from fuel cells to renewable fuels and chemicals to ocean energy. Rahul is an active investor in early stage climate tech and health tech companies, and he earned his BS in chemical engineering from MIT and an MBA from Harvard. So if you're all set, Rahul.
Yep, can you hear me all right?
Perfectly.
Great. Well, again, thanks, Chris, for that kind introduction and the invitation to participate. As Brett said, really appreciate that presentation you gave. That would have been quite helpful to me, 4 or 5 months ago as I was diving into the space. As Chris noted, I come at concrete from the clean energy world, and I was primarily focused on making investments in early stage climate tech companies when I caught the concrete bug, if you will. Sort of looked at a couple of investment opportunities and dug in further, and one thing led to another, and sort of late third quarter found myself as CEO of CO2 Concrete. So as Chris said, CO2 Concrete's a spin out from the Institute for Carbon Management at UCLA. We are focused on commercializing a sustainable solution for the $500 billion precast concrete markets. Here we go. So our solution involves two things: a formulation and a process that produce a concrete that can meet existing specifications while delivering at least a 50% reduction in carbon footprint out of the gate. As Chris said, we've got some plans that give us a roadmap to get that down to carbon neutral and carbon negative, but where we're starting is what we have today, and that's a 50% reduction. Our solution has three really unique aspects to it. And the next slide here. So first, on the formulation side, we've got one new ingredient that we add to the sort of recipe list that Chris highlighted, and that's Portlandite, or calcium hydroxide. So this is a readily available commodity chemical, sells for about the same price as cement. It's made from limestone in kilns that are very similar, if not identical, to the cement kilns that Chris showed, except they run at lower temperatures, which means they result in a lower carbon footprint for this material. And one of the great things about calcium hydroxide is that it converts into calcium carbonate, which is the main compound in limestone, in the presence of dilute CO2. So unlike a lot of other approaches, doesn't require concentrated CO2, and it does so at ambient temperatures and pressures. So this is kind of the second key feature of the approach, is this ability to use dilute CO2. And this eliminates the need for and the costs associated with capture, purification, and compression. And from our perspective, this is really critical for a commodity product like concrete. Third aspect is sort of unique aspect is that this approach enables us to dramatically increase the amount of the supplementary cementitious materials that Chris described. These are materials that have been used over the last couple decades, but usually at very small percentages, and we can we can jack those up significantly. And beyond just the amount, this approach allows us to use a much wider range of supplementary cementitious materials. So moving into materials that historically have not been able to be used for concrete. And this is good, not only because it allows us to cut costs, but helps industrial players to solve some pressing waste management issues that they have. Okay. As shown on the little cartoon that's on the right here, this solution is operationalized by us partnering with existing concrete producers that are located near CO2 sources, or by building new concrete production infrastructure near those sources. So in one case, we perform a sort of secondary curing step using CO2 at the CO2 source. In the latter case, we would integrate steam and CO2 curing when those facilities are built. And we're sort of focused on the former case in Western markets that aren't growing particularly fast, and the latter in higher growth markets where putting up new concrete production facilities is happening much faster. Okay. So to summarize, we reduce the amount of limestone-based materials. We increase the amount of low-cost waste materials, and this all results in a lower operating cost and increased margins for what is typically quite a low-margin business. Some of the CO2 reduction that we get comes from the shift in materials, and the rest comes from the utilization of CO2 in the curing process, turning Portlandite into calcium carbonate. So this all keeps capital costs low, since we don't need to have the carbon capture step, and from our analysis should lead to very compelling financial returns for those investing in these new curing facilities. And it's this economic return for investors in combination with the size of the opportunity and the large per ton carbon footprint reduction, which we think it will enable a gigaton scale opportunity. So that's kind of what we do. Let me talk a little bit about where we are. So R&D on this approach has been underway at UCLA since 2013. And this past summer, we hit a major milestone with our first field trial. Show you some pictures of that project. So our pilot system combines a full-scale curing chamber, which is essentially a modified shipping container, with subscale gas processing equipment. And these pictures show the system deployed at a coal plant in Gillette, Wyoming. Top row, you can see sort of flue gas being piped directly from the stack into our equipment, which you see on the center left. There's a curing chamber on the right of that picture and some gas processing equipment in the back. It's all off-the-shelf equipment. We partnered with a block producer in South Dakota to produce blocks to our formulation, partially cure them with steam and deliver them to us in Gillette. This was all in the middle of the COVID storm, so quite proud of the team's ability to execute and get this done as scheduled. In addition to fulfilling the technical goals of the project, we produced over 10,000 blocks, which will be used for homes and buildings in California, Wyoming, and South Dakota. Those blocks all meet the ASTM C90 standard. So in addition to the project, DOE-funded project we were working on, this work completed the requirements of the NRG COSIA XPrize competition, in which we were one of 10 finalists, along with some of my fellow panelists. We're kicking off a second demonstration using that hardware this month in Alabama. We've got a third lined up also in the Southeast for Q2. And the purpose of these additional demonstrations is to show that the process works under a range of environmental conditions and with a range of flue gas sources. This is something we're quite comfortable with from our lab testing, but there's nothing like showing it at scale in operation. So we'll be doing that over the first half of this year. And with that, most of the key technical risks have been sort of retired, and we've got some incremental process improvements underway. Again, DOE funded at UCLA, and our main focus on the company side is on commercialization. We closed the seed financing in December. We've got location-specific feasibility studies underway with large CO2 producers and concrete producers in the US, Europe, and India. We're aiming to have our first commercial plants online by the end of next year. So one final point I'll make before turning it back over is that we're a few weeks from kind of relaunching the company with a new brand and name, et cetera. So don't get too invested in the CO2 concrete name. If you're interested in staying in the loop on our progress, you can, of course, follow us on our LinkedIn page, and we'll transition that over to the new name and brand here shortly. So with that, I'll turn it back over to Chris.
Thank you, Rahul. That was great. And everyone, thanks. Keep the questions coming. We have some really questions that I know panelists are already looking at. So looking forward to getting into depth on those during the discussion. But again, keep them coming. So now we're going to move on to Apoorv Sinha, who is the founder and CEO of Carbon Upcycling Technologies. To many other distinctions, Apoorv is a Forbes 30 Under 30 Energy Award in 2020 and an alumni of the Energy Futures Lab. And Carbon Upcycling Technologies is one of the 10 global finalists in the Carbon XPrize as well, which Rahul just referenced. Prior to founding CUT, Apoorv served as a research manager for Zero Core Technologies, a Calgary-based oil field service and technology development firm. And Apoorv earned his master's degree, Bachelor of Science degree at Georgia Tech, Georgia Institute of Technology and Chemical Engineering. Take it away, Apoorv. Can you hear? Are you okay? I think you're on mute.
Yeah, I can hear you. Thanks,
excellent.
Chris.
Let me know if you have trouble getting the slides up.
Yeah, shouldn't be a problem. Perfect. Thank you. Thank you for the opportunity to be a part of this panel here. I just kind of chuckled there right at the end of Rahul's presentation. I'm glad that they had their name changed the first go around, because there was a lot of confusion between our name and theirs till about a year ago. So yeah, happy to see that things are moving along for them. Just to introduce myself, my name is Apoorv. I think Chris has pretty much covered up a little bit of my background, but for Carbon Upcycling, to give you guys an overview, we're just about 6 years old as a company. We're Calgary-based. We're a Canadian operation. And our intent from the beginning has been to upcycle wastes, not just carbon emission wastes from the air, but also solid wastes, and upcycle them in a way that can help us with building a more sustainable future. Essentially, what our solution does is it carries out mineralization at scale. What we've found over the last 6 years is that we can activate a range of different natural materials as well as byproducts of industrial processes, such as fly ash that's produced from coal power plants, blast furnace slag from steel smelters. And we've even found that petroleum coke and some of these other materials that are made from petrochemical industries can be activated to absorb CO2, such that the CO2 actually gets embedded within the solid framework of these adsorbents. Unlike processes that are trying to capture CO2 or get CO2 from a low concentration to a high concentration, similar to the work that Brett's doing at Savante, we're actually looking at chemically absorbing the CO2. So we actually want the CO2 to intrinsically be incorporated into whatever solid material we use, with the intent being that when that material then ultimately finds its end use in an application like in construction materials, that CO2 remains sequestered. We have been able to file 3 different patents. One of them is already in the national patent phase. And we've been looking at advancing our technology through an umbrella of different patents that cover applications in industries ranging from pharmaceuticals to batteries to construction and plastics, which has been our primary focus so far. One of the things we've been very proud of in what we've done is how much we've scaled. So back in 2014 in the fall, when the company began its work, we had a proof of concept prototype, which probably had less volume inside than like a medium cup from a Starbucks. And you can see there, the gauge itself is almost bigger than the vessel. And just here, participating in the Carbon XPrize that Rahul was just talking about, we have now commissioned our largest reactor to date, the ADA reactor that you see here. The scale doesn't do it justice. It's about 5 times bigger than the reactor in the green here, right next to it. But that unit has already shown that it can do anywhere from 8 to as many as 24 tons per batch, and that has led us to achieving the milestone of having scaled up our work by over 7 orders of magnitude since we started doing some of this testing back just about 5.5 years ago. The Carbon XPrize really did provide us the platform to do that. Generally, the construction industry has been quite slow moving. There'll be some context on that, I'm sure, during the discussion that we have in a few minutes. But ultimately, I think what we found is, both from a regulatory standpoint as well as the low margins that are involved in the industry, there's generally an inertia that has to be overcome whenever a new solution is being offered. And the XPrize really gave us kind of a short-term goal. And there's a lot of literature around how open innovation and prizes and competitions can accelerate the rate of innovation in slow-moving industries. There's some really good books on that, and I think the XPrize is especially in a nascent field like carbon utilization, has really, at least from our perspective, given us that short-term incentive with the prize money, as well as the network and the brand awareness that it offers to the companies participating, an accelerated pathway to engaging with these players in a time frame that otherwise would not be natural. Where we've gone with this setup over the last couple of years is trying to work on an integrated setup that could either work at a point source emission, like a cement factory or a cement kiln, where you have access to some relatively concentrated CO2 emissions, and then being able to combine that through a capture process, which might involve membranes, like a couple of projects we're working on, or involve collaboration with groups like Savante that we've worked with in the last couple of years, essentially to capture that CO2 from the flue stack of the kiln, and then feed that into our process where it can actually be absorbed and mineralized into a solid product. But really, one of the nuances, I guess, of carbon utilization, which isn't immediately clear, is that the majority of the emission reductions actually come by replacement of cement, as opposed to the reduction of CO2 that's being absorbed. And that is the case with us. I think that's the case with pretty much every technology in this space, because cement does tend to be one of the most carbon intensive materials that's being used at the kind of volumes that it is. And to that end, I think one of the major challenges that we wanted to overcome last year was actually have some field data to show that this doesn't just work in the lab. This doesn't just work with well cast cylinders in a controlled QC environment, but rather can be cast out in the field and still provide these kind of improvements. And the most exciting and gratifying achievement for us through what was a pretty challenging year in many different ways was being able to get 6 field deployments within the city of Calgary here in Alberta, where in 5 of those results, like the very first one, we didn't actually reduce any cement because we wanted to have a reference to go off of for future projects. But in the last 5 that we've done, we have reduced the cement use in that mix design by 10%, and still consistently showed that the final 28-day strength, as well as the 56-day strength, was superior to what that reference was showing with that additional cement. And the reason that that's important is the ready-mix market is over 90% of the global concrete market. There is the precast space, which is more niche and covers some of the smaller kind of volume opportunities, but the ready-mix market is generally where most of the concrete gets poured. And so being able to show double-digit cement reductions in that space, and also get the third-party data that we're able to last year to show that not only is this CO2 embedded fly ash material that we produce able to produce those strengths, but also meet the regulatory standards around physical and chemical compliance, get superior durability data, whether it be sulfate resistance or alkali silica reactions. We found that gamut of data that we're able to produce out in the field to be very exciting. So just to talk very quickly about what those projects were, they ranged from slabs for driveways to piles for foundations, to even flooring for a weed greenhouse, which very much I think is in line with the Canadian brand here over the last couple of years. As we look into what we wanted to do this year, I think we really just wanted to we want to use the work that we've done last year to create sales opportunities and demonstrations within the US in particular. We were fortunate in 2018 to become the first carbon utilization company that NYSERDA accepted into their portfolio. And as Chris is aware, we're very much underway in creating a beachhead market in New York. We're actually going to have a small facility out there. We're hoping it was going to happen last year, but we're very confident that it will this year. And we're also making some headway in California with a couple of partners as well. And so the intent now, what you can see on the bottom left hand corner of my screen, is just bulk bags of tons and tons of ash that we've treated with CO2. And this is exactly the product that we've shown that 10% cement reduction in. And so our intent is to engage with partners over this year to be able to do pours, relatively small ones, anywhere from 1 cubic meter up to 100 or a couple of hundred, where you're talking about 1 to a dozen truckloads at a time, and really demonstrate that what we're showing here in Canada is replicable, not just across North America, but in other parts of the world as well. And there was a question asked here in the chat about the economic incentive, and I think it's important for me to finish by saying that, as Chris mentioned in his presentation, over 90%, 80 to 90% of carbon emissions for a cubic meter of concrete come from cement. But it's also important to know that the heavy majority of the cost of a cubic meter of concrete comes from the cost of cement. So anytime you're able to displace Portland cement with a supplementary cementitious material, whether it be, even the treated fly ash that we deal with, which not only is fly ash, it not only involves the cost of the logistics and procurement of that ash, but also the treatment of that ash with our process. What we have been able to show with our 15-ton-a-day setup in Canada is that end product is still cheaper than the price of Portland cement. And so there is not only an environmental argument to be made here, but generally one of the reasons that the top 5 cement companies in the world are all looking at expanding the use of these alternative cementitious materials is primarily because there is a cost driver there. Because running these cement kilns at those high temperatures, even with the economies of scale factored in over the last 200 years, this is a process that has been absolutely nailed down. And yet there is a possibility of significant cost reductions, in the 1 to 3% range per cubic meter that not only our technologies, but any technologies that work with SEMs provide. So, very happy to participate in this and learn more about the progress that some of the other groups are making here. And, more than happy to field any questions you may have about how you might be able to engage. So again, thank you, Chris, for the platform, and I look forward to the rest of the panel.
Great, thank you, Apoor. A very important point you just made there at the end about the intersection between cost savings and carbon reduction. I think that's a theme consistent sort of across the discussion today. And so I'm excited for our last panelist, last but absolutely not least. We have Christy Gamble. Christy, can you hear?
I can hear, yes.
Fantastic. So while you're getting your slides up, I'll tell people a little bit about you. As Senior Director of Sustainability for CarbonCure Technologies, Christy drives CarbonCure's mission to reduce 500 megatons annually of carbon emissions by 2030 from cement and the concrete industry. CarbonCure manufactures a technology that enables concrete providers to utilize post-industrial carbon dioxide in their manufacturing processes in order to achieve significant embodied carbon reductions without compromising concrete quality. You're about to hear about that. At CarbonCure, Christy collaborates very closely with designers and builders who seek to reduce the carbon impact of their building and infrastructure project. Great. Excited to hear from you, Christy.
Thank you, Chris. Well, thank you for having me on the panel today. Very excited to be here. And hi, everyone. As Chris mentioned, my name is Christy Gamble. I'm the Senior Director of Sustainability with CarbonCure. I'm also a board member on the Carbon Leadership Forum, which is an international organization of individuals who are on a mission to reduce embodied carbon in the built environment. And this concept of embodied carbon, as Chris has mentioned, is a really critical topic of today. And concrete plays a significant role in this challenge. As Chris mentioned, one of the key levers to decarbonize concrete is this concept of carbon capture, utilization, and storage in concrete. And did you know that CCUS, carbon capture, utilization, and storage, is a viable strategy to reduce embodied carbon in concrete today? CarbonCure is proud to be the world leader in the CCUS industry. And I'll share a little bit about our story and how we're operating in concrete plants today. So first of all, what is CarbonCure? Our mission as an organization is to reduce 500 megatons of carbon emissions annually from the cement and concrete sector by the year 2030. This is equivalent to taking over 100 million cars off the road every year. Now, how we do this is through CO2 utilization in concrete. Specifically, the technology that we have commercially available today beneficially repurposes carbon dioxide to reduce the carbon footprint of concrete without compromising the concrete's performance. Our technology is currently operating at over 275 concrete plants across primarily North America. About 90% of our operations are within the States. We're also in Canada and a few other select countries across the globe. To date, we have been utilized in over 8 million cubic yards of concrete that have been delivered to construction sites, ranging from driveways in rural Indiana through Amazon's headquarters in Northern Virginia. This so far has resulted in over 100,000 tons of CO2 saved to date. The process is compliant with ASTM C494 Type S admixture standards. So how the technology works is it's a retrofit technology that integrates with existing concrete operations. We install this technology that injects the CO2. And starting with the beginning of the process, CO2 is collected from large emitters and purified by industrial gas suppliers. So CarbonCure does not collect the CO2. This is collected by industrial gas suppliers who currently have technologies installed in ethanol plants and fertilizer plants. They collect, purify, and distribute the CO2 to the market. It's the same CO2 that's used for carbonated beverages. So we use that CO2, but when we introduce it into concrete, we chemically convert it and get rid of it. Now, in the future, we look to capture or use CO2 that's captured from innovative sources, cement plants, for example, and work with other innovators such as Savante to utilize more CO2 that's captured from other industrial processes. Now, going back to the process to how it works today, the industrial gas supplier will install a tank at every concrete plant where our technology is installed. You can see an example of this tank here. It's a pressurized tank. And under pressure, the CO2 exists as a liquid. Our technology is a precise metering and injection system. We're drawing this liquefied CO2 from the tank and injecting a precise dosage into the concrete as it's getting mixed. So what happens is when that CO2 enters the concrete mix, a chemical reaction occurs where that CO2 reacts with the cement that's in the concrete mix and immediately begins to form a nano-sized calcium carbonate mineral. So we take what would otherwise be a greenhouse gas and we convert it into a mineral that becomes permanently embedded in the concrete. And this is all based off this chemical reaction that's the key to many of these kinds of CCUS innovative solutions. So the cement, these calcium ions from cement and the CO2 in the presence of water attract each other and convert into a calcium carbonate mineral, which is basically limestone. So what we're doing is creating this solid limestone nanomineral that becomes embedded in the concrete. And this nanomineral is really key to the concrete's performance. What's happening here is these tiny, tiny particles bind to the cement grains, increase the surface area of the cement grains, and make that cement more efficient. This mechanism results in higher strength. Higher strength allows for concrete producers to optimize their cement content. This means they can actually reduce the amount of cement while maintaining the same compressive strength as they've had before. Ultimately, the concrete that's delivered to site meets the same compressive strength and same fresh and hardened properties as the traditional concrete made without CarbonCure. So from a contractor's perspective, the fresh properties such as set time, the workability, pumping, air contents, temperature, finishing are all maintained. Hardened properties, freeze thaw, pH, density, durability, which is a really particularly important property, especially for engineers, color, texture, these are all maintained. So it's the same concrete, but with a reduced carbon footprint. How much CO2 can be saved? It really depends. There are quite a few different factors that come into play and different amounts of optimization that can occur for different kinds of concrete mixes. It typically works out to about 20 to 35 pounds of CO2 saved per cubic yard. If I don't have any other kind of information and just want to do a back of the napkin kind of calculation, I would assume about 25 pounds CO2 per cubic yard is saved. Now, this does start to add up to some real carbon savings on a project by project basis. And these are just examples of projects where our technology has been utilized to reduce the carbon footprint. You can see a wide range of locations, wide range of applications. In Halifax, a hockey arena. In California, the LinkedIn campus. In Indianapolis, Infosys Innovation Hub. Calgary, Alberta, the concrete paving for an airport tarmac. Chicago with McDonald's. In Hawaii, we're talking about Department of Transportation paving. I've got this great aquarium in Atlanta. And of course, as I mentioned earlier, we're really excited to have recently begun construction on Amazon's HQ2 in Arlington, Virginia, which in itself is estimated to save a significant amount of carbon. So these are just some examples of the projects that have been supplied across North America. We're also gaining acceptance within various government procurement agencies, including the Chicago Department of Transportation, where CarbonCure is an approved material, Hawaii Departments of Transportation, City of Honolulu, and quite a few others that we expect will come into play this upcoming year. So with that in mind, how can you help to reduce concrete's carbon impact? Well, first and foremost, communicate your commitment to embodied carbon throughout the supply chain early and often. I cannot stress this enough. The supply chain of design through to manufacturing and supply of building materials is very convoluted. And so the clearer the communication, more consistent communication for embodied carbon is so critical, because so much of this commitment gets lost in translation in this process. Design for the strength you need. Use supplementary cementitious materials and low carbon cement. To clarify, these processes are compatible with CarbonCure. They can be stacked with CarbonCure for stackable carbon benefits. Consider longer curing times. This is an emerging strategy that I see gaining more and more traction. Remove unnecessary prescriptive concrete specs, such as a minimum cement content. And I'm sure we're going to get into this in discussion. This is one of the key challenges that we face. And instead consider performance-based concrete specs that ask for strength and performance as compared to asking for a certain amount of cement. Finally, specify and or approve CO2 mineralized concrete. So with that in mind, build for the future and build with CarbonCure. Building or infrastructure projects may save as much as hundreds, if not thousands of acres of trees would absorb over the course of the year. So who knew that building with concrete could be like planting trees? Chris, back to you.
Great. Thank you, Christy. That was excellent. And thanks to all the panelists for really just great overviews of what they're doing. Really gives us a good landscape of what's happening. And that kind of leads into my first question. Again, there's some really great questions. I see many of them are being addressed directly by panelists, but I'll probably raise some of those for further elaboration shortly. But what I think is a great kind of fun, open question. I think it's fair to say for a lot of folks, myself included, who kind of stumbled in backwards to low carbon concrete a couple of years ago, that it's really having a moment. There's a real focus on this now. I think there's no fewer than 4 panels in the next few weeks that I've counted globally on this subject. So I'm curious if anyone wants to sort of comment on what are some of the big trends or even sort of bets that you might sort of anticipate over the next 5-year timeframe about what are some of the major sort of developments that might emerge both in terms of technology and market development and incentives in this space over the next 5 years. Apoorv, you want to kick us off for that?
Yeah, I mean, that's a great way to get a shout out, I guess, Chris, because I think the work you guys are doing on the low carbon bill in New York is a great case in point. I think generally speaking, we do expect procurement policies from government players, like whether they be federal, provincial, state or municipal level. Like we expect them to incentivize the use of carbon emissions in construction and other areas where there's a legitimate, high volume sink opportunity. So I think I'm hopeful. I guess one of the bets we're making is that those kind of trends continue and proliferate across the world. Another important one, I think, is seeing a better accounting mechanism for the carbon impact that's actually produced. I think, I was in Norway at almost exactly this time last year with Brett, actually. I think we were having a beer around this time. And one of the things that we saw, which I found very insightful in the Norwegian approach, was a very numerical, quantitative approach with regards to how they track emissions with regards to a project, not just from a material standpoint, but from a logistics and from an overall project delivery standpoint. And so taking that holistic view and being able to prioritize, where the winds are coming from. They actually had the Powerhouse unit, which is this consortium of different producers within Norway that came together, and their headquarters in Oslo use like 70% fly ash in their mix. So like instead of having generally in Canada or the US, you'll have an 80% Portland cement mix, which has 15 or 20% of an SCM. It could be steel slag out in Ontario. It'd be fly ash out west. But generally speaking, like you'll never move too much away from that. But in that mix, they actually said, yes, we know Norway's cold. Yes, we know there are some challenges with using these SCMs, but they completely flipped that around. They used 70, 80% SCMs and only 20% cement. So from a carbon reduction standpoint, they had a very clear line of sight on what type of approach was going to get them to that goal of, being 20, 30, 50% lower than the baseline of business as usual. And I think seeing a bit more transparency and accountability on that, I think carbon accounting is still only kind of in its nascent phase. And I think seeing that emerge over the next 5 years is going to be another great area, because I think it's going to do two things. I think within all the competitive landscape is going to help us identify where we stand. But I think hopefully, I believe a lot in collaboration, and I think hopefully it gets us all to kind of start working together as well to say, okay, what's the best way for us to combine our different offerings into something that might be larger than the sum of its parts.
Yeah, I agree with you entirely there. And I know that's an active conversation that the Urban Green Council community is having. That's the tricky thing, but the exciting thing about embodied carbon is it just entails a whole new sort of methodology for accounting and transparency. So I agree with you 100%. Anybody else on the panel want to sort of add to this this thread around what's in the next 5 years?
Sure, Chris. I'll just chime in. I'm sure everybody's heard this many times before, but I think it's in the next 5 or 10 years that the big change in the world is going to be the regulatory frameworks that get more widespread, more solid, and really get down to the details that companies, emitters, and technology providers can make business models that work. I think that's going to. There's a great example that the U.S. has done with 45Q tax equity. It's gone through a lot of details. There's been a lot of input from the industry into it. And I think examples like that are going to happen worldwide. Canada, Europe, Asia, they're coming. You could find another 100 companies such as ourselves to talk about technology, but without these frameworks that have to be solid, they can't disappear, right? They have to be solid, well thought out. Without those frameworks, nothing happens, right? Or it's very, very difficult to have anything happen that's meaningful. So that's going to happen, I think, in the next 5 or 10 years, because the world is now serious about tackling the climate change issue. And I think I'm excited to see that, because we're ready. These technologies, everyone on this panel is ready to go, right?
Absolutely. Well, I think that leads into a number of different things that, we want to talk about. One is the ready to go part and how that collides with what you might call sort of a built-in conservatism of the industries of cement and concrete. It's been with us for several millennia at this point. And across the supply chain, I think there's different kinds of barriers that are just sort of tied to, inertia to a certain degree. And I wonder if you can, each from your different points within the supply chain, if you can talk a little bit about how sort of business as usual is a specific kind of barrier to getting to exactly what you just described, Brett, accelerating things. And I know Christy, Carbon Cure is actually a market leader that's very much out in the world right now. So you might be encountering this most on a daily basis. So maybe you can kick off.
Yeah, absolutely. Well, you're absolutely right, Chris. There's certainly a pervasiveness of just hesitation for change within the concrete industry. But a lot of that is in response to what the concrete industry is able to do because of regulatory environments, procurement strategies, because of this concept of prescriptive specifications. I'm going to give you an example of what this means. So a prescriptive spec is something where a procurement agency or a structural engineer requires a certain amount of cement to be used on the concrete that's delivered to a construction site. If you noticed from the picture of all the different kinds of projects that we've supplied to date, you didn't see a picture from New York, and there's a reason for that. We do have a couple of great providers in some parts of New York State, but we've really struggled to work with concrete producers in New York. And just last week, we were having a conversation with a concrete producer who said, we'd really like to partner and do innovative, sustainable things, but our market won't allow it. Our market is requiring us to provide concrete that meets status quo. And no policy for innovation is the same as basically having a policy that supports status quo. And that's ultimately the challenge that we face, is that current procurement strategies are using an old method of basically prescribing the way that concrete is supposed to be made, and it prevents innovation and prevents sustainability.
Yeah, I mean, that is one that I wanted to raise explicitly, and I wonder if particularly Apoorv and Rahul, and actually Brett as well, this prescriptive versus performance-based divide is a real barrier. And I think from an advocacy point of view, I think it's very underappreciated about how significant. There's something about the dryness of it, I think, that causes people to not focus on it. But it couldn't be more essential. I don't know if any of the other panelists want to weigh in on how they encounter this specifically as a barrier as well.
Yeah, no, I think it's a great, I'll chime in here next. It's a great point. I think one of the things that seemed very analogous to me when I jumped into this space, going back to my experience on the sort of advanced biofuel side a decade ago, is we came in to that space making alternative diesel fuel chemistry. All the incentives in the space were set up around ethanol or conventional biodiesel as a specific formula, right? And we had to do a lot of spade work on the Hill just to sort of work the technology neutrality argument, and in the end it was successful. So I mean, these are winnable arguments. I see a lot of similarities between the sort of conventional way of doing things in with new fuels as I do in here, and I'm relatively new to this space, but it does strike me that there's a lot of similarities. I will give a shout out here if folks are interested in a specific opportunity that a few of us are coming together to try and speak to these things as an industry. And if you're interested in sort of the notion of industry coalitions on this front, it's not just the technology providers like those of us on this panel, but all the stakeholders that are involved, whether they're CO2 emitters or concrete producers, right? We sort of need that whole cross section to help do this. But I've seen it work very successfully on the fuel side, and quite optimistic about what's possible here when you get a cross section of industry stakeholders together. So you can reach out to me, you can reach out to Chris. I think Chris is aware of what we're going to start doing on that front, as well as some of the other people on the call, and we can get you looped in that regard. Great.
Apoorv, unless you have something to add, I wanted to tag something onto that, but go ahead. It looks like you unmuted.
Yeah, just very quickly. I think you're exactly right. I think it is a super dry area. Like there's, no one wants to dive into the specs of like how much has been prescribed into a recipe for a mix design. Obviously, we're not as privy to some of the details there that Christy mentioned. Like we're, I guess, much earlier along in our journey here. But one of the things that I find interesting in that is just kind of looking at where that might have come from. Like I think I alluded to this in the prep to this this panel here. Like the guy who invented Portland cement, Bill Aspidine, he came up with it in 1824. It took him till 1843 to build his first plant. So it took him almost 20 years to do that. He had a bunch of data issues and stuff, but he finally got it going. And then what's really interesting to me is it was in 1889, like less than 6 years later, that China had its own Portland cement factory. So you think about back in those days, this is pre-commercial flights, this is all being done over ships and stuff. And yet, the other corner of the world had already figured out how to make cement at that point. And I think what I find fascinating about that is, generally like within the time frame of the world we live in today, where like change is expected to happen in 6 months or a year, it is going to take a lot longer to get these behaviors to change. But this addiction, I guess, to Portland cement has built over 250 years, and so it's important to keep or 150 years, I guess, and it's important to keep that in mind. I think a lot of it boils down to staying power, and I think that's one of the things that CarbonCure has done so well is they've been around long enough to be able to leverage some of these changes that happen, and I think that's, I would say, almost 80% of the battle is that behavior is going to change over time. Like those specifiers, they get lazy sometimes. They like to have a recipe to go back to. It helps the BASFs of the world. It helps a lot of these providers because they're basically baked into that recipe. But, as climate and these discussions become more important. And I think Rahul makes a good point about getting all those stakeholders together and creating a unified voice. But I think ultimately the pull from the end user is what's going to change things, whether it's architects, whether it's, urban engineers, like civil engineers working for cities and things like that. It doesn't matter how small that initial project is, but a truckload by truckload, you can start changing that paradigm. And I think if we do that, hopefully in 5 years' time, that aversion to changing these recipes and becoming more performance based in spec design becomes the norm.
Yeah, great. And this is good. What we can do is, I want to get into some policy questions, but I think we can just pause for a second. Urban Green has a really diverse national and even international community, but a lot of us are focused in New York City, New York State, and the tri-state area. So maybe we can talk about these. And the audience are construction people, architects, and engineers. So they're doers that are doing projects. So not surprising that they're asking questions about what are specifically, and Christy alluded to some of the barriers that we're seeing in New York City and New York State. And related to that, they're asking when are your products going to be available here in New York City, New York State, and New Jersey? So if you can speak to any of those questions that relate to the local context, that'd be great.
Well, I'll start in that we do have a couple of local providers of carbon cure concrete products. So we would encourage anyone who's in New York State to ask for CO2 mineralization in their concrete or concrete masonry units. What you can do, though, is to start to review the specifications that are being made for concrete. Whether you're a structural engineer or someone who's in a different part of the process, and determine whether or not there are these prescriptive specifications for a minimum cement content or an overuse of maximum water cement ratio that can inhibit these kinds of innovations. And also include allowance for certain types of innovations, such as CO2 mineralization, CO2 utilization solutions. This will go a long way to helping bridge the gap in the supply chain. Now, there are a lot of other things that can be done as well. I mentioned different strategies to reduce the carbon footprint of concrete, longer curing times, maximizing SCM content, so supplementary cementitious materials, which are cement substitutes. This has been around for decades, continue to do that while encouraging innovation for other types of solutions as well. The other thing is to support local policy. So government is one of the main procurers of concrete. And government policy can really lead by example, create a precedent for private construction to be able to follow, and also really make a market available for concrete producers to adopt innovation. The LECLA policy is some of the best policy that I've seen for encouraging innovation. It provides a carrot that incentivizes good behavior by concrete producers without really, excluding anyone else from the market, but basically allowing these concrete producers to adopt the kinds of innovative solutions that make sense for their operations.
Well, thank you for, I know a little bit about LECLA. I've heard about it lately, but it's definitely, let's get right into that, because you just raised a really important point. I mean, there's many roles that government can play at various levels to overcome some of these obstacles and accelerate change. Brett mentioned, 45Q, which is particularly relevant for, the cement sector. And maybe Brett, you can speak to that a little bit more, but just staying with LECLA and procurement. Yeah, I think it's worth pointing out that as opposed to other sort of climate technologies where government procurement can have a major role, it's really worth stressing that government is probably the single largest states or the single largest consumers or purchasers of concrete in any given state. So their behaviors can really influence what happens in the market. And LECLA is a policy that's been introduced in New York State. I posted some information. Last week it was introduced in New Jersey, and there's a number of other states where it's being considered. And at its center, it has this idea called climate competition, where basically you're incentivizing providers to adopt low carbon technologies that they feel they can implement cost effectively, and then they get essentially a discount rate applied to their pricing, so they appear more cheap or competitive during the selection process. So if we could crit that for a second, I'm wondering, I know Christy is very, very familiar with it in Apoorv, but if either of you want to comment on that policy specifically, or other policies you think that relate to procurement that could be high impact, would love your insights and thoughts. unless I just summed it up perfectly. Go ahead, Apoorv.
Where do we go?
Christy, did you want to go first, or Rahul? I don't know. Yeah,
go ahead, Apoorv.
Maybe I'll just go ahead and So I mean, just to echo what Christy said, I think it really is a very progressive form of legislation. I think one of the things that I found good about the way it's structured is it follows. If you read the book Reinventing Fire by Amory Lovins, like he talks about a lot of government procurement working that way. He also talks about how the private sector can start using that same type of framework where you've got some premiums that are performance based and they ebb over time because as the technology scales, it's deemed to become more price competitive. And really the best analogy on that is the renewable sector, particularly around the solar market, right? Like there was a lot of incentive to get that off the ground. And there are some cases where it was botched, like Ontario up here in Canada. But in other cases, like in California and much of the Western US, I think that was deployed in what is a beautiful case study. And I think what it ends up doing is, to your point, like once the government begins to make those moves and once these technologies get to a point where they're, scaling and there's, a few companies getting to the type of market traction that the CarbonCure has been able to achieve, like this field as a whole would synergetically grow and it would get to a point where institutional capital is not scared anymore, where you can look at offtake agreements and, get analogies to some of those major renewable projects that even 15 years ago, I remember when the 10 finalists for the Carbon XPrize were announced, we were all at the Bloomberg Energy Conference. And I remember going to one of these sessions by Longi Solar, which was, one of the top 10 solar producers in the world. And I was talking to their CTO for an hour over a drink. And he mentioned that he couldn't even think 17 years ago that this type of thing could be real. Like he thought, it was such like they had no idea where they'd make their next penny. It was all being subsidized by the government at that point. And for him to think that now they're looking at multi, megawatt projects every week and getting deployments in India that were cheaper than coal, like, those kind of things were just absolutely beyond the realms of imagination. And so, it's hard to draw a line. Like it's hard to, like for me, it was kind of interesting to say, okay, like there are some parallels there to like how ridiculous it feels, as to the goal that we're striving for. But to see them having done that and some of the critical, I guess, portions of that came from government procurement strategies, I think was an important, validation of the effort that LACLA is taking. And I think, as you know, Chris, like we're very much strong proponents of it and think that kind of effort does need to translate to other regions as well.
There have been studies shown that the CCUS market has the potential to be a $1 trillion market by the year 2030 and can achieve gigatons of carbon emission reductions if procurement policy is put into place. And that's a really key if. This type of procurement policy will enable the commercialization of these amazing solutions that are being developed. CarbonCure is a market leader in CCUS right now, and we fully expect to have a lot of competition at our heels in the next couple of years because of policy like LACLA that's going to encourage companies to continue to innovate and incentivize more companies to enter the space and get to a point of market traction where we're achieving real-time carbon savings in real-life projects. And that's what this policy can do.
So, I'll just make a comment on the 45Q.
Thanks. And Rahul, I would be interested. Go ahead, Brett.
On the 45Q and how that relates. It's $50 US dollars a ton for sequestration or for utilization. And that is a number that is going to get some projects off the ground, but they're going to be the low-hanging fruit projects. So they're going to be in the regions that already have infrastructure. They have the specific site features that allow a low-cost project to happen, right? So it's not going to be wide scale. It's going to start the process of getting projects off the ground, but we really do need these other types of incentives as well, coupled with that, to really get CO2 capture and utilization in all areas of the country, right, including New York. So you need both. Right now, we're really concentrating on 45Q and where that can make projects happen in the early term. But eventually, when these other frameworks get put in place, then it'll allow for business cases to be made across the country, right, and across the world. But it's going to take a little bit of time and way more emphasis on the end user, as we've all been saying, right? We even as the public, we have to start really thinking about, okay, where does my concrete come from, and what's the footprint of that? That's not something that anybody has ever thought about before, right?
Yeah, it's lying in plain sight. That's
exactly.
part of it. It's the fish in water. You become oblivious to its, how present is. Rahul, I don't know if you have something to add there.
No, I think, everyone's covered the two big ones on my list were usage incentives, like 45Q being example, or procurement. So obviously, I think anyone would put those at the top. I think if I was adding a couple more to that list, would be dollars for, in the case of technology where we've got capital to deploy, right? Dollars to help with deployment of first plants. Again, models that have been used in other climate technologies, just applying those here in this sector. I think then two pieces I'd add in terms of how do we make these work effectively, right? And I think just to hit home that we need to make sure that as we roll these out, these incentives are technology neutral, so we don't repeat the mistakes of the past on that front. And that, I think one thing that strikes me, again, just sort of coming at this new over the last few months, is that we need to make sure that every group, whether it's a state body, local, federal, that's putting something together, doesn't have their own independent approach to carbon economics, or where we draw the boxes. And so, having some common methodology and framework for that is going to be critical to make this all efficient. So I know there's people working on that, but something that needs to happen in parallel.
Yeah, absolutely. And I thank you, panelists, as well, for responding to questions that have come in kind. There's still some very technical ones in there. So if you see one that grabs your eye, please respond to it. And I also want to mention around LECLA that there is some motion towards a federal LECLA bill. And I just want to give a shout out to Carbon 180, which is an advocacy org that's really sort of driving that, along with some other organizations, NRDC. And so I just posted actually a white paper that I was lucky enough to co-author with Carbon 180 and my colleagues Shuchi Chalati there and Naeem Merchant. So you can see that in the Q&A. It's a good breakdown of procurement and concrete. One of the things that you said, Apoorv, that I come at this as a solar guy, which in some ways is the opposite of concrete. This old, slow, illustrated solar thing, just in my relatively short career, has just accelerated. And I think it has, what you guys are doing has some markers that bode well, I think, for it in a way, in terms of the speed and innovation. And if we can do what Rahul said about, set a framework and then let the leaders innovate. And one of the things I think is really encouraging, which in some ways reminds me of solar, is that all of your technologies, even Brett, yours, is they're integrated hardware into existing plants and across the supply chain. So there's so many opportunities for impact here. And even in the absence of incentives, just the diversity that's represented on this panel is really, really encouraging. So again, I think that bodes well. In the New York context, one of the things I'm very interested in too, that not to get too wonky, but we have, one of the nations in the world's most aggressive emissions reduction policies on the books that's really sort of animating things here in New York State. And one of the pieces of that is, it's by 2050, net neutral emission, but there's 15% of that can be from offsets or carbon removal and carbon utilization. And what I'm interested, just in my fellow New Yorkers who are sort of listening to this, I think that was conceived more as what we maximally could do by reducing emissions in the power sector, transportation. But I think it's a real opportunity for New York State to take that 15% and think more proactively about how do we make that our sandbox for making sure that all the technologies that you guys are bringing into the market actually happen, and really create some goals around carbon utilization that are part of that 15. But anyway, I'll leave that at that. I do want to, there was a couple of questions here that I just want to make sure to get answered that I have heard before that I think you guys might know. There is this question, which I said it before, about the abundant materials that make up concrete. I have heard more as a local constraint, issues around sand shortages. And a number of people have emailed me that over the past few weeks. Is this a real thing? And to the extent that you have an answer, like, let us know if it's more of a local or a global problem.
It can be a challenge that some producers are facing from a supply perspective, but to be honest, it's not a significant barrier to sustainability and innovation. Yes, it's one of the many challenges that the concrete industry does face is material shortages and labor challenges and all sorts of different issues that they're facing. And these are the kind of things that are top of mind for them, which is why it can be challenging sometimes to make sustainability the top of the mind because of these different kinds of issues that can be at the forefront.
Great. I will ask a question here around sources. Obviously, we're talking about utilization of carbon right now, front and center. It's very much a focus on using difficult to abate industrial sources from cement and other industrial sources. But I wonder, for me, I'm a direct air capture advocate, a technology that is nascent, but that pulls carbon directly out of the air. And it seems, at least for a few, and I hear Upur, but with Christy and with Rahul, and even with integrations with more conventional CCS, there's a real business case, it seems, to actually integrating air capture on site to kind of reduce dependency on carbon supply. And I just want to know, is that on anyone's radar here? Possible integrations with direct air capture.
I can start there, Chris. I think, as I mentioned in our talk, we're starting out of the gate with partnering with power generators, cement plants that have dilute CO2, but that's also a hurdle for us, right? Or barrier. I don't think it's going to be a thing that caps our market in the near term, but as we look out longer term, right? The notion of us building a good business in parallel to watching developments on the direct air capture side, and we need something very different than sort of most folks in the space, meaning going from sort of ambient to 3, 4, 5%. It's sort of a different challenge, but I'm quite bullish. If you look out over the next 5-10 years, that sort of approach is going to eventually allow us to cut the cord. I mean, part of what I would say there is, though, it's we've talked a lot about sustainability in the panel so far, but I think a lot of this speaks to a lot of the challenges we've talked about, from sand, the incentives, et cetera, speaks to the need to really drive the economics of the processes we're working on, right? Because that creates space for a lot of these other challenges. And at the end of the day, I think the thing that's going to move the stakeholders in these markets faster than any policy will do is the creation of margin for them and profit, right? Like eventually that's what led to the inflection points in solar, for example, and anything else. Is we've got to figure out a way. You make this profitable, significantly more profitable for a concrete producer, and they're gonna move.
Chris, I'd just like to say that Svante has partnered with Climeworks, the Swiss-based direct air capture company. We're partnering together to reduce the cost of direct air capture. Of course, it's more challenging because it's only 400 ppm, but also you can put that direct air capture system anywhere, so you can potentially save on transportation of CO2 and whatnot. So, and also on industrial sites. You could look at coupling capture from a flue gas and direct air capture, because there's a lot of waste heat at industrial sites that could be used to help drive direct air capture. So there's a whole bunch of integration opportunities there, and we're keen on moving forward with direct air capture as well. We need them all, right? Really is we need to do all these things that we're talking about.
Yeah, that's an interesting possibility, Brett, that I think is really emerging, is the piggybacking of DAC onto carbon capture and using that waste heat.
Absolutely.
That's a really exciting development. Apoorv, go ahead. Sorry, I think you're about to say something.
Just very quickly, I think, you're asking about like it being on the radar. I think generally, to the point that Brett made, I think the challenge, of course, is just, there's a thermodynamic limit with how energy efficiently you can do that. But having said that, I think it ultimately just boils down to how that technology piece meshes with the economic piece, right? And I think generally, like, my guess would be that DAC is going to see more prominence in sectors like plastics or consumer products, where the volumes are lower, the margins on the product on a per kilo or per pound basis are higher. And, you know, with Climeworks, I mean, we all know Tito, I think, from the Air Miners group, like, he's actually launching a product here where he sent us a tank of CO2 from Climeworks that we then embedded into a product that we made, that he's then making into a consumer product that I think he intends to start selling this year. And we think that that's probably the first phase of this, is like these niche, you know, premium products that'll go off first. And as DAC gets more prominence and is able to leverage economies of scale, it might become more relevant to construction. But I definitely think that, like, construction will be way further down the line for DAC use than, for example, a company like Savante. So it will happen. I think, you know, that's one of the perks, I guess, of having a platform tech, where you kind of get a little bit of understanding of where people are going. But I think it's like Brett said, I think it's definitely got a space. I think they're actually doing a very good job, like, especially out at the Capitol and stuff, in creating an awareness and creating a bit of momentum from a legislative standpoint. And actually, I think that's a great lesson for CCUS generally to learn from DAC. But yeah, I think it's going to be a while, I think, before we see any tangible pilot projects in construction that combine DAC and, like, construction materials, just because of the low margins and high volumes.
We'll see about that, Apoorv. We could place a bet, maybe have another panel on that.
Sure.
But let's do this. Actually, this has been a great, excellent panel. And I would like to give the panelists an opportunity to just make a short sort of closing statement. And if you want to, if anybody wants to hazard a guess or place a bet, by what year we'll see carbon negative concrete available on the marketplace. Christy, you want to get us kicked off?
You're throwing me on the spot here.
You don't have to answer that. I just said if you want to.
I'm so aggressive. I'm going to say we're going to do it at 2030. Let's do this, guys. If I can make just a statement about how you mentioned that 2050 is the goal for many different organizations to decarbonize. It aligns with the Paris Agreement. As part of the Carbon Leadership Forum, I've seen the modeling. If we don't start to implement CCUS solutions now, we will not reach those goals. We can't afford to spend the next decade in research trying to figure out developing a strategy. We need to start implementing these solutions now. So the solutions that I had mentioned around prescriptive to performance specs, supporting local legislation, CO2 mineralization. If there's one place that you could start, just call your concrete producers. You know, forget the supply chain that's so convoluted. Call your concrete producers and ask what they can do now, and start that process. Start the dialogue today.
Agreed. Rahul.
I need to get off mute there. No, just wanted to say thanks again. It's been a really exciting journey for me over the last few months, sort of diving into building materials and construction. Still learning a ton, but it's fantastic to engage with peers like this group here, and to see the enthusiasm from the architectural engineering community, and look forward to continuing to work with everyone on this to get to the vision we just talked about for the last hour and a half.
Great. Brett?
Yeah, thank you for inviting me on this panel. It's a lot of fun. I'm really excited about what's happening in the cement industry to do with CO2. And I think between 2025 and 2030, we're going to see just amazing changes in this industry on all fronts. So quite exciting. Great.
And Apoorv?
Yeah, I'll just finish by saying it's, given how small the field is right now, a really, really small step can go a long way. I think for people that are looking to get involved in this space, especially if they come from an end user's background, it doesn't take a lot. It takes a truckload or two or a small demonstration, to really get people going. And if there's enough of those, I think you can accelerate us reaching that tipping point that then makes this business as usual. So, it is a slow moving industry, but we shouldn't underestimate how much of an impact these small steps can have. From our perspective, that was the reason in my closing slide I mentioned, think about a truckload and think about using that just to show people that, some of these objections about being green always comes at the cost of being economically unfeasible. And, those kind of objections, if people see real on the ground examples of that not being true, I think it can start swaying people's behavior. And I would just urge people to consider that as they go back and reflect upon what they heard here. Yeah, and I would just say if we can help in that regard, like more than happy to chat.
Yeah, and that's a great closing message to end on. Again, looking at this through solar lenses, and I think Rahul, who has some experience in that, can attest to this. It's about getting it out into the world in any capacity you can, and things lead on from there. And sometimes we talk about giant gigaton goals and huge industries. We lose sight of how important it is to making local progress and how that can really start to sort of drive momentum. So, well, this has been excellent. This definitely touched on everything I hoped we would and more. And I really want to thank all the panelists again for participating, and for Urban Green for providing the opportunity for this conversation to happen.